Perfect. Good evening. Thanks a lot, Felix, for your flexibility in shifting me to be the last presentation. I'm going to present you or tell you something about an ongoing flagship project that is funded by the Austrian funding agency right now. We already heard presentations about these projects last time from the FH Adelberg. And I see also that Peter is online, and also see that my colleagues from the Montana University in Leoben are also online. So I'm doing this presentation on behalf of the whole consortium here. Digital Energy Twin, this is the name of this flagship project. I'm going to tell you something about the motivation, the digital twin definition, the objectives, the challenges, and the outlook. So just that you know that what is upcoming to you. Well, when we submitted the proposal to these projects, we were aware that we are within some megatrends that we have to deal actually with. So this on the one side, Industry 4.0 that will lead to an increase of the productivity of the industry of up to 25%. Secondly, we are within the digitalization, and we are aware that actually right now already 50% of the world's largest companies are using digital twins, and everything is within a roadmap that was defined also here within Austria. But when we're looking at the increase of productivity and the large companies already doing it, we have to be aware that at the same time we want to decarbonize the industrial energy system. I mean, this has to be then done sustainable and very efficient in that way. And while the digital twin in the past, so some years ago, was mainly used for logistics and increasing the productivity itself, we do think, and this is the motivation behind it, that this can be perfectly linked to the energy demand, or at least optimized design and operation of the energy demand. Within this flagship project, we are doing this for AT&S, what is one of the world market leaders in the production of printed circuit boards. So they are doing this in the medical sector, for industry, for computer communication, automotive, and IC substrates. And I mean, as they are producing PCBs, of course, digitalization is high priority on their side, and they have defined very detailed visions and objectives. So they want to decarbonize the energy system, not only on their production site here in Leoben, they have another one in Austria, and they have several others in Asia. So digitalization was already on the agenda. What they wanted to do within this becoming a CO2-free production is mapping the entire system, validate real models that they have already for the energy supply utilities, but also the demand. What was their motivation behind it is clearly that they expect from us a very good basis for an investment decision. The whole production sites, production lines, the supply utilities from the energy perspective are very, very flexible, and it might be, or it is the case that from month to month they completely change the system, and therefore it was very hard in the past that they have a very solid ground for these investment decisions if they want to decarbonize the system. And of course, I mean, the other things, digitalization and digital twin can be used for employee training. We developed a vision together with them that by implementing virtual and augmented reality, I mean, this is a perfect basis for the Energy Manager 4.0. I always tell this, the vision behind it, that the energy manager that is actually working in Leoben was traveling a lot in the past, going to Asia to the different production sites, and his vision before Corona was already that he can stay in Leoben, and expects that the digital twin might help him, that just putting on a VR or AR lens, that he has the possibility to look around in the production sites in Asia, therefore high multiplication potential. Well, why is it that valid for AT&S? They are mainly consuming electricity and gas, so mainly power. They are using this together with gas for the boilers, mainly for producing heat. They have a chiller. We do know exactly what is the energy demand on site, and what they are thinking about and were thinking about in the last years, that they want to completely change their existing energy supply system by substituting fossil fuel, integrating renewables, a lot of possibilities. And we do think that the digital twin allows us, and the digital energy twin in that case allows us to design and operate the optimized system. And this is tackling the challenges that they were facing in the past. The modeling approach, and we already heard this from the colleagues presenting their projects, not only today, but also in the other sessions. I mean, when we are talking about the digital energy twin, we are not only looking at the main logistics and productivity issues, we are looking at the energy supply system, so each utility that is already there, and we are looking at the main production steps that are consuming most of the energy. So we want to link the energy demand with the energy supply utilities. So you have different possibilities to apply these modeling paradigms, physics-based, data-driven based. To be honest, and you will also see this in my findings, in the very beginning, it was for us somehow seen as an easy thing to do, to decide between the physics-based and the data-driven modeling. What at the end turned out that this is not the case. So this is the challenge that we are facing actually. The models that we develop should be really simplified, of course, based on a good validation. And at the very end, we want to integrate the models of the supply utilities and the demand in an integrated optimizer of the twin. So the twin itself should really come out with clear recommendations, a clear strategy, how the existing system can be optimized, but also how we can implement renewables energy technologies and also energy efficiency measures directly. Well, the portfolio behind it is at the very end. We started this project in 2019. We are more or less in the middle of the project, so 2 years to go. At the very end, we want to a ready product, the digital energy twin software for industrial energy systems. That was, as my colleagues from Vorarlberg have already developed, I have already presented last time, is now already developed and operating for the digital factory at the FH Vorarlberg. And our strategy now is to transport and transfer the findings to the digital twin software that is going to be implemented at AT&S. Holistic simplified energy models, and this always having in mind simplification. We all know here in this round that, I mean, you can spend a lot of time in developing models, and at the very end, if we have this vision that we develop solutions that can be multiplied easily to other sectors, other companies, we have to ensure that these models, the findings that we get out of this development will enable us the simplification in a way, and by this enable the multiplication. Data security and management is a very important thing. I mean, this is completely clear to us. We have a standalone work package only dealing with these issues to fulfill the requirements and expectations from AT&S. And I already mentioned this, the Energy Manager 4.0. So the idea behind it is, I mean, if we already collect all this data, if we are going to develop models, well, let's use this information that we have to be visualized in a nice way in an augmented and or virtual reality at the very end. When we're talking about energy demand, and just one slide on the modeling itself, it's not only the energy demands of a process. The challenge that we are facing and where we are actually working on is that we have to link the product quality with the energy demand. So it's not just saying, look, you have to ensure a certain temperature in a production bath, for example. This is always linked to chemical reactions inside such a bath. What is the temperature has to raise within you can control this system? What is then really doing the coating of a PCB, for example? What is the effect on the waste heat, on the waste water? Which ingredients do you have in the different baths? And if you have an output of one bath, you always influence the next bath that with the product, you bring another chemical, for example, into this bath. A lot of parameters, and the approach of the modeling is that we find out the main driving forces for the model itself, and by this ignore the others and simplify the models at the very end. And by this then copy paste this approach to other production lines within AT&S mainly. And the big picture behind it, so on the bottom here you find the different production steps. So we identified now already which production steps are the most relevant ones in terms of the product quality and mainly the energy demand. And then this is what we are actually really working a lot on. On the top, you have the supply level models. So of course, there are already some models in different simulation and modeling frameworks. So what we did already is, for example, for the heat pumps, we selected the most appropriate models for it. We did the parameterization of it. We did the validation of it. So this is ready now. The same is for the chillers. It's almost done. And if we have everything ready, then the simulation will be set up. We are going to export it to a digital twin software. We have a software partner here also in our consortium. And on top of it, we put the optimization of the whole system. And then the optimization means in terms of the design of the system. So really implementing new renewables, as already said, but also optimizing the operation itself. I have to be honest, the approach of the twin is not like this, that we have a direct communication of the optimization with the real control system. Here we stop to a certain extent in the optimization and say whatever comes out in terms of recommendations is a kind of a information, and it's up to AT&S at the very end to implement it or not. So we do not target actually right now that we have a direct influence on the control system itself. Yeah, data management, already mentioned this, very important. We are all aware of it. We already knew in the beginning that this is going to be a challenge. It turned out in the discussion with such a large company that is linking data with different production steps, and is always in responsibility towards the customers, their clients at the very end. It's very difficult how to treat data, how to deal with data, copy data from their internal server to an external one. So you really have to ensure that nothing is going outside of the company, and this is a very, very big challenge for the digital twin. And therefore we have different tasks with which we are working on the hardware side, but also the software side. And finally, what I already mentioned is this virtual and augmented reality. So whatever we are going to develop is going to be, to a certain extent, transferred and exported to a digital twin in a virtual and augmented reality. We are not able to deliver everything or visualize everything in this reality, but we pick out some relevant things, and especially again, the FH Vorarlberg is doing here a great job. So we are already able to visualize the digital factory in an augmented reality and also in the virtual reality. And right now we're discussing with AT&S how to address this also for them directly. Why is this important? Because the content management system for virtual and augmented reality has to be set up. And if you already have a lot of data in that case, I mean that it's setting up the database of the twin. We always have in mind, okay, we want to use this data also for a content management system at the very end, to use it in an energy manager. Finally, coming up with some challenges and findings that are not really surprisingly, I mean, we heard it more or less from every partner here. It's a big approach that we are following here. It's the challenge of having very different disciplinaries working together here. Very different approaches that have to be combined and focusing on what we have to deliver towards our client here. But at the same time, it's a challenge, but especially it's a potential to optimize and set up the twin here. The modeling itself is the big challenge. I mean, we're all aware of it, and it depends on the data quality and availability. This is what we recognized and saw in the first 2 years. Sometimes we found good solutions. Sometimes, you have to be honest, we are not able to develop solutions, so we have to find some nice workarounds. But I'm pretty optimistic that we will be able to do this. And the data management system, this is the most important thing. So in an industry, normally you always have 2, 3, 4, 5 different data management systems. You have to bring them together and then bring it to a data management with which the twin at the very end is able to work with. And what we want to do is for the design and operation. And I think Thomas Kurz is also online today from the Montana University. So here from the energy supply system, we are actually focusing on the operation itself, the optimization of it. To a certain extent, we consider the demand as constant right now. We are at the same time in discussion with the suppliers of production baths. But here we have to be very straightforward, that we are not lost in all different possibilities here by combining the global criteria with the specific criteria of different technologies, and at the very end always having in mind that the product quality is the big picture that we have to fulfill. The outlook, as I said, we are in the middle of the project, so we are doing this still modeling for the demand and the supply. This is clear. What is expected from us is that we are going to support AT&S within their decarbonization strategies. And we do believe that we will be able to do this. And whatever we are going to develop here will be able or will enable us to transfer and multiplicate it. And therefore, the setup of the models has to be very generic without any process-specific information, what would be confidential and no way to do it. So this is the approach behind it. This is the outlook that we want to deliver here. And finally, as I already said, it's a big consortium, but very, very fruitful collaboration. We are doing it for AT&S. We have, on the one side, very good partner in terms of really doing audits at AT&S directly, having a long experience here. We have the FH Vorarlberg with very well experienced in digital factories, together with Eberle Automatische Systeme, who is the digital twin provider. We have from the scientific part, 3 universities plus the FH Salzburg responsible for data security. And this is well embedded also within a very nice advisory board on national level, but also European level. A challenge to coordinate it, but it's really fun doing it, accepting all the challenges. Yeah, this is my last slide, so I'm happy to answer some questions if there are.
Thank you, Jürgen, for this high-level insight into the flagship project, Digital Energy Twin. Martin has a question right away.
Thank you for the nice presentation. I would like to, I have a question to the virtual reality and augmented reality applications. So therefore, I discussed a lot in the last 1 and 2 years about some applications, and it's always a challenge to implement such devices in a plant site environment because of security reasons or whatever, and yeah, you know it, I think, but that's the reason why I'm asking you, what are the applications you're looking for, and what are the applications with the most impact from your thinking?
I mean, I completely agree with you on the challenges in terms of data confidentiality and who can use it, who can access it. I have to be honest that within this large flagship project, augmented and virtual reality is only a very small part. What we achieved by now, I mean, we have very good partners here. This is the FH Vorarlberg with experience in augmented reality, and we have Johanna Birker from TU Graz for virtual reality, so really a game development partner here. So what we're doing, or what we have already achieved, is that the digital factory at FH Vorarlberg, you can already access this location with augmented and virtual reality. And by this, we have proven that this setup of the realities is able to work with the data management system that we set up for the factory there. And right now we are discussing with AT&S what would they expect from us. I mean, the vision of having this Energy Manager 4.0, this is not addressed in this project. This is the vision that the Energy Manager in Leoben is putting on the lenses and then is able to walk around in Shanghai, for example, in the location. Right now we're discussing with them what is possible within this project. What we want to do is not having an interface really influencing, for example, a boiler or a heat pump or whatever. It's more visualizing the energy demand or the productivity, for example, of a production line or a boiler, something like this. So it's more visualizing right now with no interface or interactive interface. This is the vision, but yeah, for this we are focusing on the big other challenges here.
Thank you very much.
say this virtual augmented reality aspect, is this something that the industrial partners that they want, or that they are asking for, or is this something that's pushed from the academic side?
I think both. Yeah, I mean, in that case, we have, anyhow, if you visualize whatever you develop, it's always a nice thing. Yeah, and complex things can be put in virtual reality, and then it's easier to understand what is ongoing. So we are using this mainly for dissemination right now. This is definitely clear, and therefore ATNDS for them it's really, really interesting, because they are thinking about every visitor who can come to Leoben has the possibility not going directly to the production line with all these issues of, again, confidentiality and hygienic things. They just put on the lenses in the welcome reception and have the possibility to see what is actually ongoing. So this is what ATNDS really likes behind it. Yeah? And I mean, for us academia, I really like playing games. So I'm doing Call of Duty and all these nice things, and so therefore I like it. And for the academia, yeah, it's more the game development behind it. But I do think that for dissemination, explaining what is ongoing, augmented and virtual reality is a very, very nice way to do it.
But don't you need like lots of graphic designers to make it look really nicely?
So it's not a challenge anymore.
All right.
I also expected that this is really, really difficult to do, but this is not a big thing anymore.
Nice. And like coming back to the flagship project, what do you think is going to be the impact for the customer, like for industry, by like applying this your digital twin?
The challenge that ATNDS is, I really focus on ATNDS right now. Yeah, that most of the production lines have a thermal energy demand, but this is mainly supplied by electricity. And at the same time, at the location in Hinterberg, they have the challenge that the power capacity is not sufficient anymore. So what they expect from us is that they get out of the twin clear recommendations how to avoid these peak loads, and by this have a much more constant production and ensure the power or energy supply. And what is the big impact will be that based on historic data, the twin will be able to simulate how the system would have looked like if there were already a PV or a solar thermal or another heat pump. And therefore you can prove that over a period of 3 years, this would have achieved these CO2 savings or these cost savings. And with this, they have a very solid decision or investment decision basis for the future. And then they do think that the risk for the investment in renewable energy will be significantly reduced. So in the operation and the design, this is what will be the impact.
So just to paraphrase, to make sure that I got it correctly, you sort of avoid making predictions by saying, what if I implemented the PV module like 3 years ago? And then you can just use the historic data to like rate the PV system. Yeah,
this is really for the implementation of new ones. I mean, we work together with ATNDS in different other projects already in the last 5 years, and we have already designed different possibilities to decarbonize the system. But I understood their argument saying, well, how the system looks like right now, this is a good thing, but we do not know how this system will look like in 2 years. But if you're able to simulate the whole system very dynamic for a longer period, of course, based on historic data, but then at least you can say, look, if you would have done this 3 years ago, this would have had this impact already. And then it's a much more solid basis for the investment decision.
Yeah, you avoid lots and lots of assumptions.
Pardon, can you repeat this?
You can avoid a lot of assumptions about the future by just looking at historic data.
Yeah. And at the same time, we know that the twin, so if you implement, for example, solar thermal, the twin exactly knows how to implement it in the most appropriate way and saying, okay, there's this is what Thomas Kurz is actually doing from the Montana University. He's setting up this priority list, how the different cascade supply utilities can be optimized. And then solar thermal is part of it, for example, and defined on technology-specific KPIs, you can ensure that the whole system is operating in the optimized way.
Mm-hmm. Yeah, I think these large-scale industrial processes are a really great area of application for industrial twins, because you can sort of like adapt the model as the plant evolves with new devices being added, other ones going out of service, so that children can actually like grow with the system or evolve with the system. Really neat. I like it. Are there like more questions to Jürgen?